Hello everyone, welcome back to Unite Coaching. Now this is the third part of our series, learning the STAAD Pro Connect Edition. So I'll name it as tutorial 3. I'll keep the location where I want to save my model. I'll select this units as metric system and again click on create. So the STAAD Pro will open with the default setting. Now what we will do, we will analyze a complete simply supported beam with UDL first so that you can have a practice of this. So what I'll do, I'll first of all go to view and select the front view because if we want to draw a beam, it will be a front view. I'll go to front views and front view. Then I'll click on 0 and click here so that a node is getting created. If you want to select this node, I'll click on select node cursor and select this node and go to geometry and click on translational repeat. Now once I click on translational repeat, this window appears. Here, what I'll do, in the x direction I want the distance to be 5 meters. I'll keep it as it is and only one beam I want. If I click on link steps, not only this node will be copied but also a beam will also be drawn in between these two nodes. So I'll click on OK. Now see, a beam is drawn here. So this is end of your geometry part. Now we'll go to the properties. I'll select a predefined section. For that, I'll go to define. I'll select a rectangular section of 0.23 by 0.45 meter. I'll tick this option. Make sure you tick this option so that the material is already taken as concrete. I'll click on add, close. Now this beam is added in the list. I'll select this beam and click on selected beams, assign, and yes, now it is getting assigned as section R1. Now I'll go to directly supports, create a new support which is a simple support. For that I'll select the pinned support, click on add, support 2 will be added. I'll select both the nodes. If these nodes are not getting selected, make sure you click on select and node cursor. So now these two nodes are getting selected. I'll click on assign to selected nodes, assign, and yes. Now these supports are also assigned. Now I'll go to loading part. For example, this beam is carrying a UDL of say 4 kilonewton per meter. So I'll go to loading, load cases details. First of all, I'll go to loading, then load case details and click on add. The type of loading, keep it as none because we don't know whether it is a dead load, live load. So I'll keep it as none. I'll name it as UDL of 4 kilonewton per meter. Okay. I'll click on add and close. I just named it. Okay. Now the list is added as 1 UDL of 4 kilonewton. I'll click on this and click on add. And this time it's a member load. See, UDL is known as a member load because it will be acting on a member. So I'll select this member load and click on uniform force. I'll put the value of -4 because why minus? Because the unit it is 4 kilonewton per meter, but it will have to be acted in the downward direction. So I'll select the 4, click on and make sure the axis is a global y axis. Click on add and close. Now this is as it added in the list. Now what we will do, we will assign this same load to the beam which we have as drawn here. So for that, I'll select this, click this, assign to selected beams, assign, and yes, now the load is also assigned here. If you see it in 3D, for that we will go to view, go to the isometric view. Now the beam is showing like this. Okay. Now what we will do, the next part will be the analysis part. Okay. So for that, I'll go to analysis and click on run analysis. Make sure the errors are 0 and no matter how many warnings you get, but error shall be 0. See, we are getting 2 errors. Let's see what errors are there. So I'll go to click on done. Once you click on done, this window will appear. See, it says finish command line in the load data is not there. And the second command is above line contains error as data. That means the last finish line is having some error. So how to identify that? Because once you go on practicing this things, you will understand why it is showing that message and why not. Okay, I have understood what is the error, but I make sure that this error comes because you should be able to edit these errors or solve these errors. So for that, I'll go to utilities and go to command line. Once you click on command line, this window will appear. It's like a coding for the STAAD Pro. See, it shows we have some error here. So what was the error? I'll write that we have not written perform analysis. That was the error. Okay. If I click this and if I want to save here, I'll save it and again close. Now it will regenerate the model and again click on analysis and design and run analysis. And this time there will not be any errors. See, 0 errors are there. Now I intentionally put that error for your better understanding. Why? See, you cannot directly click on run analysis. For that, before that, what you should do, you should click on command analysis command. And if you don't want any print right now, so you just click on no print and click on add, because I have already added in the code line. Because let's remove that first. I'll remove that. I'll click on save. I'll close that. See, now we don't have any perform analysis line. If I want to analyze it now, what it will show? It will show some errors. It shows 2 errors. I'll close this. I'll close this option. Now what I'll do? I'll first click on this analysis command, no print and add, and then close. Now if I click on run analysis, it will be analyzed properly without any single error. So this way you can analyze it. Now I want to see what is the shear force, what is the bending moment value. For that, I'll go to post processing. It will ask what type of load you want. As we have only one load, so it is already in the selected category. Apply, OK. And once you click on that, you can check the reactions. Then you can check the beam results. Beam results means if you click control button on the keyboard and the cursor, if you put the cursor up and down like this, so this beam will show the bending moment. I'll select the view as front view. Now it will be very good one. See, if a simply supported beam is supported, it means it is carrying a UDL over entire span, the bending moment will be like this. Why it is in the downward direction? Because the load was in downward direction, right? Now if I want to see the value, how you can see the value? You have to go to results. Okay. Now there are various options. First of all, I'll show you the various options. Utilization ratio, it is generally used in the steel structures. Beam stresses, MX, MY, so many. Now this time it is MZ is on. If I turn it off, it will disappear. If I want to see the shear forces, I'll click on FY. And if I want to zoom it, just click on control and the cursor you have to move from the on your mouse like this. The shear force diagram will look like this. The values, if you want to see, you can see it here. See the maximum axial forces, maximum bending moment, maximum shear forces. The maximum bending moment it shows at a distance of 2.5 means at the center, this one. Wait a minute. This one. It is how much? Maximum bending moment. It is maximum bending moment is how much? I'll show you it. You have to go to beam results here. In the beam results, you have to go to maximum bending moment. This one. Maximum bending moment is how much? It is 110.635. If you click manually, if you solve it manually, you will get the same results. How much value you have to take? You have to take the span as 5 meters of the span, and the UDL we have taken. You have to go to again analytical model, loading, and the UDL was how much? 4 kilonewton per meter. So by the formula WL square by 8, if you check it, you will get the same answer. So thank you for watching this video. In the next video, we will add the point load also on the beam. And again, that video will be for your practice. We will add some eccentric point load, central point load, so that your practice is very good. And go on, we will go on increasing the difficulty so that it is completely and permanently fixed into your brain, this STAAD PRO Connect Edition. Thank you.